In the last lesson, we saw that we can combine the load and store instructions to store both the source and destination addresses in memory. But what if there was a simpler way? Let's say that instead of load and store instructions, LWCS provided a copy instruction with the following format. The source would contain the source address, and the destination would contain the destination address. Having one instruction instead of two similar instructions reduces confusion. We lose the immediate argument, but we can get around that by adding constants to the source and destination cells beforehand. With such clear advantages, why did computer architects decide that two instructions are better than one? To answer this question, we need to examine how real computers work. Like our simulator, real computers have instructions in memory, but real computers also have registers. Registers store values just like memory. In a real computer, the inputs and outputs of computer instructions are stored in registers instead of memory. But there aren't very many registers, so the computer will quickly use all of them. When the registers are full, the computer will stash some registers to memory to make room. Later, the computer will copy values from memory back into the registers when needed. Here is a high-level comparison. In this architecture, the load instruction loads values from memory to registers, and the store instruction stores values from registers to memory. Load and store instructions are more differentiated in a real computer, and the instruction names are now more intuitive. The two instructions have the same format in both LWCS and MIPS, but in LWCS, the source and destination parameters point to memory locations instead of registers, since LWCS doesn't have registers. Registers make computers complicated, so why bother with them? Computers can read and write to registers 100 times faster than memory. We omitted registers to make this course more accessible, but included load and store instructions since they teach us valuable memory access concepts.